This is Algebra 2 with trig. We'll be graphing quadratic functions in intercept form. We have our I can statements at the top that we'll be able to graph our intercept form with intercepts and a vertex. We'll also be able to write an equation from a table. If the graph of a quadratic function has at least one x-intercept, then it can be represented in intercept form, which is y equals a, x minus p, x minus q. So right here is a parabola. It's touching the x-axis, in this case twice, so we can write it in intercept form. Intercept form typically has some parentheses. It's going to have your a value like we've talked about in the past. The other two variables of where it crosses the x-axis is called your p and the q. We don't call them h's and k's because it's not a translation value. It's a spot where they cross the x-axis. So the intercepts are p and q. The axis of symmetry is halfway between the p and the q. So the equation for the axis of symmetry is going to be p plus q divided by 2. So you're taking the average of the p and the q to figure out that middle line, which is our axis of symmetry. The graph is going to open upwards if the absolute value of a is greater than 1, actually greater than 0. Right, sorry. This is not important. We don't need the absolute value in this case. If the a value is greater than 0, it opens upwards. If the a value is less than 0, it opens downwards. The absolute value that I was referring to deals with the stretch or the shrink, about how narrow it's going to be or how wide it's going to be. But in this case, just going up is looking at the positive or negative number of a, like it usually is in previous quadratic examples. Okay, so here's our equation. We see our intercepts. The p is going to be 1. The q value is going to be 5. So our intercepts are 1, 0 and 5, 0. They're always the opposite of what it looks like, just like when we had the h value in the vertex form. Always the opposite. To find the vertex, we have to do some work. We have to do the x equals p plus q divided by 2. So we're going to have to do the 1 plus 5 divided by 2, which is 6 divided by 2. Calculates to be 3. So the y-coordinate of the vertex is going to be plugging that 3 back into the equation. So the y value is going to be negative 2 times 3 minus 1, 3 minus 5. We plug the x value into the original equation for the x variable. We're going to calculate what the y needs to be. 3 minus 1 is 2. 3 minus 5 is negative 2. So your y value is going to become negative 8. 2 times 2 is 4 times 2 is 8. 2 negatives actually makes that a positive 8. So our vertex is 3, 8. Axis of symmetry is x equals 3. Since the a value is negative, we know it opens downwards, so it's going to have a maximum value, and that's going to be where the vertex is at, so maximum value of 8. The domain is always all real numbers for quadratics. In the range, since it's going downwards, is going to be y is less than or equal to 8. You could also use intercept form. It includes the 8, but does not include the negative.